So let us draw the frequency spectrum now. The very first spectrum I'm going to draw is of x of n, so which is x of omega. So we are going to draw x of omega with respect to omega x. If you remember, the range of digital omega is from minus pi to plus pi. So this is what we have taken. Let's say somewhere here is plus pi. So minus pi to plus pi, we have drawn x of omega, its magnitude spectrum basically. You can see x of omega is a low pass signal, and let's say it extends only up to pi by d and minus pi by d on both the sides. So 0 is the midpoint. It consists of the low frequencies, and then it extends up to pi by d and minus pi by d. We will see what happens if it goes beyond pi by d later on, and why it is important to restrict x of omega to pi by d. Every Fourier transform is periodic in nature. It repeats after 2 pi. So the same triangular spectrum is also available around 2 pi, and around 2 pi, if you write down its values, it will be 2 pi plus pi by d, 2 pi plus pi by d on the right hand side, and this left hand side point will be 2 pi minus pi by d. Please remember, this is the repetition of x of omega. The axis that we are using is omega axis, but to be precise, it is with respect to x, so it's called omega x. Let us now in the next frequency spectrum plot y of omega, the magnitude spectrum of y of omega, for which we can use this relationship. Y of omega we have defined in the form of x of omega. You can see that all we have to do is expand this summation and keep on plotting x of omega. When I put k equal to 0, I will get x of omega x. That means if k is 0, I get original x of omega without any shifting taking place. So when I plot y of omega, we will be plotting first with respect to omega x. I have to show original x of omega x as it is. So I will show the original spectrum which is present around 0 from minus pi by d to plus pi by d. Obviously the magnitude, whatever it is, will be reduced by 1. So if this is 1, it will get reduced by d. It will be 1 by d in y of d because of this scaling factor. If I now put k equal to 1, will give me the second part in this expression. It will be x of, if I put k equal to 1 here, it will be omega x minus 2 pi by d. Now x of omega x minus 2 pi by d is nothing but shifted version of x of omega towards right. Because of this sign, it's shifted towards right by 2 pi by d. So I have to shift this signal towards right by 2 pi by d. If I do that, this 0 point will go to 2 pi by d. This minus pi by d point will go to minus pi by d plus 2 pi by d, which will be pi by d. So the next spectrum will start from this point itself. This is how the next spectrum in y of omega will look like. This midpoint to which the 0 point will shift will be nothing but 2 pi by d, because it shifts by 2 pi by d, and this pi by d point will go to pi by d plus 2 pi by d, so this will be 3 pi by d. Even this spectrum value will be equal to 1 by d. So now if you go on putting the value of k, you will go on getting the repeated version of the original spectrum in y of omega. So likewise, finally, if I continue doing this, finally the last value of k that I will put is k equal to d minus 1. So let's see what happens if I put k equal to d minus 1. So I'll just write it here. If I put k equal to d minus 1, then I'll get x of omega x minus 2 pi by d into d minus 1. So this is nothing but x of omega, which is shifted by this much amount. When you shift it by 2 pi d minus 1 by d, this will be the last value. Let's see where will this spectrum be available. You can see the 0 point will shift to 2 pi d minus 1 by d, and this right hand side point will shift to pi by d plus 2 pi by d into d minus 1. Now if you do this, if you add this, you will get 2 pi by d, d will cancel out. You will get minus 2 pi by d and plus pi by d, and that will give you, so I'll just keep this 2 pi, the first 2 pi as it is, and the second term will become minus pi by d. So I'll request everyone to verify this. You get 2 pi d by d as 2 pi, and minus 2 pi by d plus pi by d will be minus pi by d. So this right hand side point of pi by d will shift to 2 pi minus pi by d, and 2 pi minus pi by d is nothing but this particular point which we already have in the upper spectrum. So my whole new spectrum will be now available between these 2 points, where this midpoint will be nothing but 2 pi by d into d minus 1. this point is nothing but 2 pi minus pi by d, and this point will be nothing but 2 pi. Now this is minus pi by d, so if I consider minus pi by d plus this whole thing, that will give me 2 pi minus 3 pi by d.